Okay, pre-cal, here's your second video about graphing piecewise functions. So in our first video, we talked generally about what a piecewise function is, and then I talked to you about a specific one that you should be familiar with from your parent graphs, the greatest integer function. But now we're going to look at graphing piecewise defined functions, and you're going to be able to see what they look like. So sometimes it's helpful on these to graph using colored pencils. I know that a lot of you are doing this electronically, so that might not be something that you want to do unless you are using something like I'm using, like Notability. Okay, so let's graph these. I am going to start with my very first function, and sometimes it helps to graph the parent function and then erase what you don't need. So I'm going to do that just to make it easier for you to watch me. So this parent function is of course the quadratic. So, and it's moved up one because of the plus one. So I've got this quadratic moved up one. I use my usual values to graph it. So right one, up one, left one, up one, right two, up four, etc., etc. So I know that my graph will look something like this. However, it's restricted to x less than 0. Well, less than 0 for x. Remember, x is the domain, so that's my x-axis right there. And if it's restricted to less than that, that means that way. So what I'm going to do, I'm going to erase, oh, poopy. Okay, I'm going to erase that, and I'm just going to put an open circle, since it's just less than 0, not less than or equal to, and draw my graph just like that. Pretty. All right, now I'm going to switch to my next graph, which is f of x equals x minus 1. So of course this is a line that goes through the y-axis at -1, and the slope, remember, if that's 1x, the slope is 1. So from -1, I'm going to go up 1 over 1, up 1 over 1, etc., etc., all the way up here. All right, this now is x greater than or equal to 0. So that is going to be all of this right here. There's my line. I know it's not very straight, I'm sorry. Okay, so that's the whole function right there. That's what it should look like. I want you to notice that where x equals 0, one of the graphs covers it, and then the parabola has an open circle. It will always be like that unless they're joined at that point. Okay, let's do the next problem. So the next one, we have x plus 2. So again, that is a line that goes through +2 and has a slope of 1. So it would look like this. Got a little bit offline there, but that's okay. All right, so this one is restricted. I can speak. Okay. It is restricted. It's less than or equal to 0. So that's right here. So I'm going to erase that line. So it's less than or equal to 0. So that's going to mean right here. But it's also greater. X is greater than -3. So I'm just going to do this. And then I'm going to erase that. Oh, that worked out much better. Okay, so there's that portion. All right, now let's use pink for the next one because pink is fun. And we've got x plus 3 squared. Well, x plus 3 squared means I've got a quadratic that's moved to the left 3. So I'm going to go over 1, 2, 3, and you'll notice it's restricted to x less than or equal to -3. So I know that less than is that way, so I'm just going to graph that side of the graph. So it's going to look just like that. Pretty. And then my last function, let's use green. I've got another quadratic, and it has moved down 2. So I am going to move down 2, and what's it restricted to? X greater than 0. Okay, so I've got to put an open circle right there. And then like my usual values. Excellent. That is what your graph looks like. Okay, moving on to the next one. All right, on number 3, we've got x plus 7. So 1, 2, 3, 4, 5, 6, 7. All right, so my line is way up there. Let's see what it's restricted to. All right, it is restricted to less than -3, so -3 is right here, so this is that dot right there. And then it is greater than or equal to -7, so -4, 5, 6, 7. It's greater than that and less than the -3, so that's the portion of the line that I want right there. So I don't need these other little guys here. All right, next color, let's use this one. And now we've just got the parabola, and it's just restricted to be less than or equal to 2, greater than or equal to -2. So it's going to look just like this. So it's just going to stop, and it's not going to go all the way up like we would normally do, all right? Because it's restricted the domain. Remember, these are all restricted by the domain, so make sure you pay attention to that. All right, and the last one, let's use blue again, we have 5. Okay, well, when we have f of x equals 5, that just means a horizontal line through y equals 5. So 1, 2, 3, 4, 5, that's going to be right here. We're restricted to greater than 2 and less than 7. Well, 2 is right here. So, and it's less than, so we're going to have an open circle, and less than 7 is going to be 2, 3, 4, 5, 6, 7. I'm going to have an open circle at 7. So that's what my function will look like. Pretty. All right, let's go on to number 4. I know this video is long. I'm really sorry. Okay, so we've got x plus 4. So we have a line that goes through 4, and the slope is 1. So that's where my values will be, right there. And we're restricted to less than -5. So -5 is right here. So I'm going to have an open circle and then less than 5. So it's going to look just like that. So again, let me get rid of these other things. I don't need those. And we'll use another color. For this right here, this is my quadratic function again, and this time it moves left 3, and it reflects over the x-axis. So that means that it's going to look something like that, right? Okay, so let's see where it's restricted. It's restricted at greater than or equal to -5. All right, so -5 is right here. And so let's look and see what that would look like. So we're going to go left 1, down 1. There's an ordered pair. Left 2, down 4. Okay, so that is where it's going to stop, right there. And then on the other side, it's going to just keep on going. All right, so that's what your function would look like. Okay, let's look at number 5. We have x plus 6, and x is less than or equal to -2. So again, this is a line, and it's going through 6, positive 6. And then my slope is positive 1 again. I'm being pretty easy with you. Okay, it's restricted to less than or equal to -2. Well, -2 is right here, so that's going to be right there. Right there. Okay, so that's what that's going to look like. All right, let's pick another color. This is going to be my square root function, and you'll notice it's negative on the outside of the radical. That means we're going to reflect over the x-axis, and this plus 2 means we're moving left 2. So normally it would look like that. So we're going to go left 2, and it's going to reflect. So I'm going to have this right here. And it says it's greater than -2. So I've got an open circle right here, and then it keeps on going that way. Awesome. So that's how you graph piecewise functions, just like that. And sometimes you'll have a situation where you'll have a graph like this that connects or joins, and anytime that happens, we're going to actually talk about how we write the domain restrictions with that one. We're going to talk about that when we graph them. So